Children, in continuous to last topic, we are going to discuss about now a resistance. Now, what is the definition of resistance? Simply not allowing the current to pass through it. Opposition to flow of current does not allow current to pass through it. So generally, this resistance is always directly proportional to length of the tube, otherwise whatever object you take here. Now this is the length, from here to here it is having what? Length. More length, more resistance. Next, resistance is also inversely proportional to area of cross section. A for what? Area of cross section. Now this part is called what? Area of cross section. Now if it is more, resistance will be less here. So that I have written here. So combinationally, these two can be written as resistance is directly proportional to length, inversely proportional to area of cross section. Now this is the proportionality. Remove this proportionality now. Replace that proportionality with a proportional constant rho, isn't it? This rho is nothing but called resistance proportionality constant. Simply we can call specific resistance. Here it is called specific resistance rho, isn't it? Also we can call resistivity, isn't it? Now here this rho is equal to what now? Rho is equal to R, isn't it? R into, now this you are sending into right hand side. We are going to get A by L. A by L. Now this will be the formula for what? Calculation of specific resistance or calculation of resistivity. This formula we can take. R for resistance, A for what? Area of cross section, L for length here. Now if you want to find out the units, how to find out the units? Now put here rho is equal to, what are the units for resistance? Simply we can take ohm. Ohm is nothing but called what? Units for what? Resistance into, isn't it? Area of cross section means centimeter whole square, okay, and length will be centimeter. Now this will be cancelled here. Now the units for the specific resistance or resistivity is equal to ohm into centimeter. This you can also write like this also, OH ohm into centimeter, or this for CGS units, right? In SI units what we can take? Ohm into meter. This is for what? SI units, isn't it? So everything we have taken like this. SI units, ohm into meter, CGS units, ohm into centimeter here. In this way we can easily find out the units for the resistance, specific resistance here. Now how to make a definition for specific resistance? Now rho is nothing but specific resistance. I am making a definition for this one by putting the formula A by L. Now area of cross section I am taking what? 1 meter square. Length I am taking what? 1 meter. Now if area of cross section is 1 meter square and length is what? 1 meter, then specific resistance is always equal to what here? Resistance, okay? Resistance of a substance in which area of cross section is 1 meter square, length is what? 1 meter, that is called what? Resistivity. In this way we can make a definition for, if it is what? 1, everything is what? 1, what we get? This will be equal to what? Specific resistance. Next, we'll take now here conductance now. Now what is conductance? Very simple. Reciprocal to resistance is called what? Conductance, isn't it? Otherwise opposite to the resistance is called what? Conductance. Conductance means they allow current to pass through. It is called what? Conductance, isn't it? What type of examples we can take? Metals, nothing but what? Electronic conductors. Electronic conductors, isn't it? Comes under where? In this. Similarly, acids, bases, salts are nothing but what? Electrolytic conductors. Electrolytic conductors, isn't it? Now already we know reciprocal of resistance is nothing but called what? Conductance, right? Now it can be denoted by the C. It is a old nomenclature. Nowadays we are using what? G. G for what? Conductance, isn't it? Reciprocal to resistance is called what? Conductance, represented by G. C or G. Now G is equal to, I can write here what? 1 by R, isn't it? Now R already we know this one. In the last slide we got this formula. We derived this formula from the last equation, right? So that will take in the next slide. Before that, what happened? Let me see what are the units for conductance here. Conductance units will be ohm inverse, because resistance will be ohm, no? For this one, if you write ohm, okay, then for the G will be what actually? Ohm inverse. Ohm inverse also we can take either MHO. Reverse also we can write. Also we can take capital S, Siemens, isn't it? Siemens, MHO or ohm inverse. All these are what? Units for conductance. Next, what is insulator? Do not allow current to pass through it. They are called what? Insulators. Pure water, urea, sugar. Urea, sugar, generally they are actually covalent compounds. Generally covalent compounds do not conduct electricity, isn't it?